Unit 4, Topic C, Lesson 20, Stretching and Shrinking Graphs of Functions. We're going to start with this one here. F of x equals the absolute value of x. Here, the x values have already been chosen for you. You plug in the x value here and evaluate. What is the absolute value of negative 4? 4. Absolute value of negative 2? 2. What about 0? 2 and 4. You have to go plot those points on the graph. You're going to do that on your graph paper as I do them here. And we'll label the graph when we get finished with it. So negative 4, positive 4. We'll go back to negative 4 and then up 4. There is the first dot. The next point was negative 2 and then up 2. We plot that. The next one was 0, 0. The next one was 2, positive 2, and then 4, positive 4. The absolute value function makes a V shape. So we have to fill this in. I'll get the line tool out and see if I can make somewhat of a decent line here. I'll make this one in red. I'm going to have to move this one over just a hair. And here's the other side of it. Like that. Label your graph. You have to label the graph. And this was f of x. So we'll come in here and do f of x equals the absolute value of x. The next one is the same function except it's been multiplied by 2. So we're going to find 2 times the absolute value of x. And I'll do this one in blue. The absolute value of negative 4 is what? The absolute value of negative 4 is not 8. It is 4. Then I multiply 4 by 2 to get what? 8. There is your first value. The absolute value of negative 2 is what? 2 times 2 is 4. What is the answer going to be for the next one? 0. What is the answer for the next one? 4. And the next one? 8. Alright, so we've put these in and we're going to go graph them. So we have to go to negative 4 and then 8. And here is negative 4, 8. We plugged in a negative 2 and came back with a positive 4. So it's going to go here. 0, 0. A positive 2 gave us a 4. And then a positive 4 gave us a 8. So now we have to graph that. I'll switch to blue. We'll go there, and we'll use this one. Here's the line. I'm going to have to move it over after I get it drawn. There's one side of it, and here comes the other side. Probably going to have to mess with that one a little bit. Alright, there it is, off just a little bit. And we have to label it. This is g of x equals 2 times the absolute value of x. Alright, we've changed the absolute value of x by multiplying it by 2. Here is the red one. This is the original absolute value of x. What happened when we multiplied by 2? What happened to the graph? To go from blue to go from red to blue, what has happened to the shape of the graph? It shrank. Yes. So if you're multiplying by 2, it's going to shrink it. Now we can go look at h of x, which is 3 times the absolute value of x. We should be able to fill this one in pretty quick. If I plug in a -4, and I'll do this in green, if I plug in a -4, what do I get back? If I plug in a -4, I get back... No, I don't get back a 4. I'm plugging in -4 into an absolute value and then multiplying by 3. 12. If I plug in a -2, what do I get back? 6. What about 0? 2. And then 4. We'll get back a 12. All right, so we're going to start with -4, 12. -4, 12. We'll do this one in green. Let's see. So it should be right about here. -4, 12. And then we're going to put in -2 and come back with a 6. So that'll be here. And then we have 0, 0 at the origin. If I put in a +2, I come back with 6, and a +4 is going to give me a 12. Here come the lines for those. I may have to draw these and then move them. I think that'll work out. Probably not, so I'll try this again. There we go. That's a little better. And then here comes the next one. I'll just draw it off to the side and then move it. Not even try to do it on the first try. There we go. And that function was h of x equals the absolute value of x times 3. h of x equals 3 times the absolute value of x. Now go back and take a look at these. Here's the absolute value of x here in the red. When we multiplied it by 2, here in the blue, it shrank. Now what happened after we increased that number and multiplied by 3? It shrank some more. So the higher the number is that you multiply the absolute value of x by, the thinner the graph is going to get. The next one is j of x equals the absolute value of x multiplied by 1/2. So I'm going to have to pick a new color here. I'm going to make it purple and darken it up a little bit. A little bit more. Okay. If I put in a -4 into the absolute value brackets and multiply by 1/2, what do I get back? I get back 2. If I put a -2 in, what do I get back? 1. If I put in a 0, what do I get? 0. If I put in 2, 1. And if I put in a +4, 2. All right, we have to plot those on the graph. So go to your graph paper, go to -4 and then +2. Let's see. Yeah, -4, +2, that's right. So -4, +2 is going to be, let's see, right there. -4, +2. If I put in a -2, I came back with 1. And we have 0, 0. If I put in a +2, I came back with 1. And if I put in a +4, I came back with 2. So we have to graph 1/2 times the absolute value of x. Here comes the marker. I'll just draw it off to the side and then fix it. It should look like that. And then we'll go over here, do the same thing. I'll just make it and then move it. You can barely see it. Well, those lines look a little different in width. I don't know why. But we have to label it. And that was j of x. So come over here, put j of x equals 1/2 times the absolute value of x. Now, what happened to that graph? Here's the original one, the absolute value of x. What happened when we multiplied by 1/2? It gets wider. Okay, so if we're multiplying by an integer greater than 1, it shrinks. If I multiply by something that's greater than 0 but less than 1, it opens up. The next one here is the negative absolute value of x. If I plug in a negative 4 into that problem, what do I get back? I get back a negative 4, right. Even though the absolute value of negative 4 is 4, I cannot forget about this negative 1 on the outside. So 4 times negative 1 is negative 4. If I plug in a negative 2, what do I get back? What about 0? And 2? Negative 2. What about 4? Negative 4. Okay, we have to plot those points on the graph. So we'll go back to negative 4, negative 4. So negative 4 is going to put me here. Negative 2 puts me here. And of course the origin is already on there. If I go to 2 and down to negative 2, I'm there. And if I go to 4, down negative 4, I'm there. And I kept that in purple. I should probably put a different color when I draw the lines. Let's make this a weird looking yellow. Okay, we'll go like that. Here is the line. And I'll fix it as I put it in there. Oops, I moved the graphs. There we go. Let's see if we can get a hold of the graph only. No, so we'll try to lock that in place. It locks everything. There's the line. And now I have a hold of it. There we go. We'll go like that. And then we'll go over here. Let's just draw it down there to start with. There we go. And we'll go like that. Did I hit it? Okay. I want to carry it all the way through. I'm afraid to touch it anymore because it may move everything. That was m of x. So m of x equals the negative absolute value of x. Alright, the original function was here in red. All we did is put a negative sign in front of it. What happened to it? It went down. It flipped it upside down. Does it have the exact same shape as the red one, only it's flipped upside down? Yes, that's because there is not a number other than 1, or a negative 1 there in front of the function. When you multiply by a negative, it'll flip it upside down. If it's a negative 1, it keeps the same shape as the basic absolute value of x function. But you can multiply it by different things, and we'll see just with this next one if it does the same thing as if it were positive. We'll go down here to negative 2 times the absolute value of x. If I plug in, let's see, we'll make this one that color. If I make this one negative 4, if I put in a negative 4, what do I get back? I get a negative 8. If I plug in a negative 2, what do I get back? Negative 4. What about 0? And 2? Negative 4 and 4? Negative 8. Okay. This is not an evaluation lesson. It is not a graphing lesson. It is stretching and shrinking. So we have to go plot it to see what has happened. Alright, negative 4, negative 2 is going to be right here. And then if I go with, let's see, I want to double check that. That's negative 4, negative 8. Is that right? Yeah, negative 4, negative 8. That's not the point we need. We need negative 4, negative 8, which should be down here. There we go. There's negative 4, negative 8. We'll ignore the other dot. The other point is negative 2, negative 4. Should be right here. There's the origin. And then we have to mirror that on the other side. 2, negative 4 should be right here. And then 4, negative 8 is right there. So we'll draw those lines, and I'll make it down here first and then move it. Hopefully I'm hitting this. That's close. I cannot do more than that because it may foul up the whole thing. It's just the way this program is. Okay. Oh good, I got a hold of it again, and there it is. Alright, let's label the graph. That one was n of x equals negative 2 times the absolute value of x. Okay, so we did this to test to see if the rules stay the same for the negative ones. Does this shrink? Yes, it shrinks inward. So the larger the integer, positive or negative, it's going to shrink. Actually, the larger the absolute value of the integer. I mean, it's just a technical thing, but I'll get emails from my Japanese friends who watch these videos overseas saying I didn't get technical enough. But yeah, if you go to negative 8, it's going to shrink it in even further. So the absolute value of negative 8 is 8. It's a larger number, so it shrinks it inward. And we're going to start off with the cube of x. That's a of x equals the cube of x. Remember, it's not a game show. You can use your calculator. And we'll start with, we'll do this one in black. If I put a negative 2 in and cube it, then what do I get back? It should be negative 8. If I cube negative 1, what is the answer? Negative 1. If I put in 0, what is it? 0. If I put in 1, what about 2? 8. So we have to plot those points. We go back 2 and then down 8. Make a dot. The next one was negative 1, negative 1. So here it is here. 0, 0 is here. If we put in a 1, we came back with a 1. And then if we put in a 2, we came back with an 8. Now you have to actually draw this in here. And it should look like this. It is freehand, so perfection may not be possible, but close to it. That is the graph of the cube of x. So label your graph. A of x equals the cube of x. This is our starting point, and now we have to plot another one to see what happened to that. And that other one is over here. So now I have to put a negative 2 into b of x equals 2 times the cube of x. So if we put in a negative 2 and cube it, it's negative 8, and we multiply it by 2, we get a negative 16. I'll do this one in blue. What if I put a negative 1 in there? Negative 2. What about 0? 1. You get back a 2. And 2, you get a 16. Okay, we have to plot these on the graph. The first one is negative 2, negative 16. So we find negative 2, go down to 16, make a dot. The next one is negative 1, negative 2. So go back negative 1 and down negative 2. And the next one is 0, 0. That's pretty easy. The next one is 1, 2. Over 1, up 2. And the next one is 2, 16. So we'll zoom in on this one, go over 2 and up 16. Now try to draw the line through there and make it somewhat similar to the shape that is on there. Before we even graph it, can you notice where the points are at? The blue one's on the inside. This blue one's on the inside. They match up here at 0, 0. Blue on the inside, blue on the inside. We've multiplied by a positive 2. So for the graph, looks like that. Make sure you label it. It's b of x equals 2 times the cube of x. Now before, when we did the absolute value and we multiplied it by 2 and then by 3 and so on, it made it shrink inward from left to right. Did the same thing happen here? Yes, it's gone inward when you're multiplying by 2. If you multiply by 3, then it should be in this area, like that, between the blue and the y-axis, and so on until it looks like it's almost overlaying the y-axis, even though it's not. So let's move into 1/2 of x cubed. If I put a negative 2 in, cube it, and then multiply by 1/2, what do I get back? Negative 2 cubed is what? Is negative 8, and we multiply by 1/2 to get negative 4. That's right. If I put in a negative 1, negative 1 cubed is negative 1. Half of that would be a negative 1/2. Put in a 0 and get back a 0. Put in a 1 and get back a 1/2. Put in a 2 and get back a 4. Back over here to the graph, we're going to have to go to negative 2, negative 4. Alright, so back 2 and then down 4, make a dot. Back 1 and down a 1/2. So I may have to zoom in a little bit for this. Back 1 and down a 1/2. Should be right there. Alright, and then we'll go over to the next one. It is 0, 0. That's easy enough. And then we go over 1 and up a 1/2. So here's over 1, up a 1/2. And then back over here, we'll go over 2 and then up 4. Alright, let's try to draw this. Now take a look at it before you even do anything. Is that red dot outside of the black? What about down on the bottom? Is it outside the black? Yes. Alright, so we can draw this one in, keeping in mind that it's going to be outside of the black, so not too far outside of the black. But there it is. And we stated before we drew it and plotted it that since we're multiplying by 1/2, which is a number between 0 and 1, not including either, that it will expand outwards. It will stretch out. We're claiming that this one, the negative x cubed, is going to go the opposite way. So we'll plug in a negative 2 and see what we get back. If I do plug in a negative 2 and cube it, and then multiply by a negative 1, what do I get? I get a positive 8. Alright, it is a positive 8, and we'll change this to green, darken it up. So we'll go positive 8. What if I put in a negative 1? Positive 1, a 0, 1, negative 1, and 2, negative 8. Alright, let's plot these and see what we come up with. Negative 2 and then up 8. Alright, negative 2 up 8 is going to be there. Next one is negative 1 up 1. There. 0, 0. and then 1, negative 1, and then 2, negative 8. We said it would go the opposite direction. Does it look like it's doing that? Okay, that's one way to say it, that it's going the opposite direction. So we will try to draw this in as best as we can. Oh, that's awful. But I can't undo it because of the program I'm using, so we'll just leave it and kind of fix it a little bit. Alright, label that, and that is some letter. Let's see, that is D. That is D of x equals negative x cubed. So yeah, it does. It flips it over. And they're still going up and down. It's just that it's reversed across the x-axis or the y-axis. What will happen to this one?
It's going to be flipped and shrunk.
Yeah, it's going to flip across the y-axis and then it's going to shrink inward. And we won't even bother to graph that one. We know what's going to happen with that.